Wow, okay. So first of all, vertical video, you dumb clown. If you watched my previous vlog video, you probably saw that I strapped some Gatorade bottles to a sump pump to make it a floating sump pump so it wouldn't get clogged up with dirt and weeds. That worked really well, but I still got pretty annoyed and pretty tired of going out every hour to check and see if the ditch was empty or full, because it does both empty out at an unpredictable rate and it also fills up at an unpredictable rate because it's being fed not just by the rain but by underground springs. So basically I needed to wire up a little control system that includes a float switch, which is what this guy is, and this output is for the pump. So you plug the pump into that. We're going to use a nightlight instead of a pump just because it's easier and more visual. And then this, of course, is the input power. And because it was easy to do, I made both fill and drain settings. So you can use this as a fill switch where it'll turn on the pump when the level gets low, or you can use it as a drain system where when the level gets high, it turns on until the level goes low again. So let me just pause the video real quick here, and I'm going to hook a couple things up. I'm going to have to plug that cord into the outlet down here, and I'm going to have to plug that pump output into the nightlight. So one thing I should have told you in the setup part of this was that this is actually a GFCI. So everything in this system is basically GFCI protected, starting about right there. Right now it's on the drain setting and the float is facing down, meaning the water level is low. When the water level's low, you have successfully drained things, so the pump should be off. And indeed, you can see the pump is off. Incidentally, just turn the nightlight off for a minute. There's a little neon lamp inside this cord, so you know even if your pump fails, you can still know whether your electronics are working or not just by that neon light being on or off. So it's kind of got a self-documenting or self-evident state type of thing going on. We're currently on drain, and the float is low, so the pump should be off. But then the float were to go high, the water level rises, the float goes high, and the pump turns on. And then eventually the pump pumps it out and the water level falls, and when the water level falls down, the pump goes off. That's how drain should work. Fill, of course, is the exact opposite. We put it on fill. The water level's low, so we're filling. The water level's low, the pump goes on. And then when the water level comes high, the pump goes off. What was that stupid Bill O'Reilly thing? Tide goes in, tide goes out. You can't explain that? So I'll throw a little circuit diagram up on this. Most of the magic is actually in the float switch. This is just basically some little, standard off-the-shelf hardware store components. A plain old light switch, just like a light switch you'd find in your wall. The GFCI outlet is just like the one you see in your bathroom. And a big rat's nest of wires. The hardest part of this electrical part was definitely hooking up 6 different grounds. One last note about the mechanical engineering. I built this little yoke out of hardware store parts, and this float has almost no way to do any kind of mechanical attachment. It's very smooth. The only thing I could find that I thought was any chance at all was there's a little groove right here, just big enough to get some of this polyethylene twine in here. So I made this sort of makeshift yoke and then I put this twine in here, but clearly this part of it needs more work. There needs to be a solid axle and then some way to attach this very smooth pump that you can't drill into or you'll compromise its water tightness to the solid axle. That was really, really difficult mechanically, figuring out a decent way to do that without being able to machine a part or 3D print a part or something. I had to buy off the shelf because the rain is coming. I can't, send out 2 weeks for a machined part and wait 2 weeks to come in. Our driveway will be completely washed out. So had to do some spur of the moment engineering.
If you're curious how the float switch works inside, I don't blame you. I was curious too. So here's the page on Amazon for it. And it kind of starts with this switch. The switch has a little nub on top, that little nub right there. When that nub gets pushed together, the bottom contact and one of the brass contacts gets connected. When that nub is not being pushed on and is just let to spring out freely, the bottom silver contact and the other brass contacts on the right is being connected. So it's very much an SPDT type of switch, and the actuator of the switch is just that little nub up on top of that. You can see that is a cherry switch, which is, if you know anything about like arcade machine switches, these are very well regarded switches. They're considered maybe the best switches in the industry. Okay, so we have our switch that can actually switch back and forth depending on whether something is being pressed on or not. How do we get from there to actually sensing the level of the water? Well, we can see in this picture, this is a cutaway of the inside of the float. And if we look more closely, the little gray thing in the back there is the cherry switch. And the little blue arm is obviously some kind of arm that's going to press on the little nub. But the interesting thing is this sort of dual-barreled or two-lobed little thing up here. I believe, based on hearing the clunk-clunk sound when I move that switch up and down, that there's a little steel ball inside here, and it has to sort of get over the hump in the middle of those two lobes in order to either get to the blue switch and turn it on, or to get away from the blue switch and turn it off. So that's my guess about how this works. You have those two little spherical chambers. There's a metal ball that can go in or out of them, and when it's in the one nearer the float switch, it presses the blue arm and it presses the switch. So that's my guess about how that float works. But obviously, if you have different ideas about how the float works, cool, drop me a comment. You know, maybe you've taken one of these things all the way apart. I wasn't willing to take my float switch all the way apart. Obviously, I needed it. Maybe in September, when the rain has stopped, I'll be able to tear it down. Anyway, just a little side note there.
So here it is in action. Plugged in there, control box there. The float is kind of halfway in the water right now. The water isn't very high, but eventually the water will get high enough to cause that float to flip upward. At which point the pump, which is kept near the surface by those Gatorade bottles that are wired to it, will flip on and pump out through the hose and over to the other side of the ditch. So I'd like to show you guys actually pumping this. So what we're going to do is we're going to set it to fill mode. I mean, I could come over here and I could lift up the float. But I'd rather just flick this over to fill, and in fill mode, when the float is down, the pump goes on. So there you go. Hope that was interesting. Nothing like a little redneck flood mitigation to deal with a wet Colorado spring.